Okay, I'm going to start with the soldering 101 with tinning the pads, using the desoldering braid to fix my errors, and then adding a component, which will happen at about the 5-minute point. I use a 15-watt soldering iron, rosin core solder, and the dimensions of my soldering wick. I am not a skilled solderer, and I'm self-taught, so these are just my tips. Start off by showing you that you have to heat the copper before you add the solder, but sometimes you need to encourage the flow of solder by touching it to the iron. You need, for the rosin, which is basically an acid, to flow from the rosin core solder onto the copper. It more or less etches the copper and creates a surface that will accept the solder. That's why we're tinning it, so that when we actually put a component on there, we'll actually get adherence, good adherence, not a cold solder. Cold solder will either break or cause sparks or burn. So here I've added way too much solder, so I'm using the braid to remove some of the solder. You can see some of the challenges I'm having is that it's not heating up. Later on you'll see a better use of the braid. So I'm fighting to get these holes free and having leaving just the pads tinned. So I've covered those holes back up again. More or less this was just too much solder put on. I got overzealous and put too much on, and here I'm trying to fix the wrong hole, so I will shift over in a second here. There we go. To back, trying to get the braid to heat up and pull that solder off of the pad and onto the soldering braid. You can see there where I had some luck was when I got over the braid that already had solder on it. Solder conducts, so just heat and electricity, just as well, I guess. So having that soldering iron tip applied to the part of the braid that had the solder on it made it easier for me to heat that area. There's a concept called tinning the tip of the soldering iron, and basically tinning the tip of the soldering iron is when you apply some rosin core solder onto the iron, and you get a nice silvery color on the tip of the iron, which also indicates that the tip of the iron will transfer heat very well. So you'll see it occasionally throughout this example where I have to add a little bit of solder or a little bit of rosin to the tip of the iron. You see here I actually overflowed the rosin onto the, I guess it's probably an enamel covering over the copper. You want to minimize that where possible. You could potentially damage the enamel. You also see where I just quickly used a wet paper towel and wiped off the tip of the soldering iron. Occasionally I'll do that and maybe go back and put a little bit of solder, from to basically tin the tip to make the solder flow better again. Try to heat the pad up first and then apply a little bit of solder. If you don't heat the pad up, it won't accept the rosin or the solder. So you have to have the pad hot enough to do that, and you can encourage the flow of the solder by barely touching the tip of the iron, but you really want the pad to be hot enough. Ideally you would heat the pad up all the way, but it seems like that would normally be too hot. So by tinning these pads, the benefit that we're getting is when we apply the component, we know that we're not going to get a cold solder, because we're at that point we're worried about the component, which is coming up pretty soon here. So you can see here I'm having some trouble getting that to flow. So I'm just having to work my way around that soldering hole. It may have been wise to clean my tip off and then apply a little bit of the solder on there to retin it. My desoldering braid is a little bit full, so I'm clipping a piece off. You notice I left a little bit of solder on the end because, again, that will help conduct and heat that braid up. So this one is going really well. Heated right up and pulled that solder right out of there. So now we're adding the component here, and it's a capacitor, so I pushed the capacitor through and bent the leads out. And my theory is that you bend those leads down before you solder them, and that will get you closer to the pad, because you don't want to rely completely on the solder as a conducting. You want to get that as close to the copper as you can. So I'm leaning the soldering iron against the component's lead and putting the tip onto the copper pad. I want them both hot to accept the solder. See, I couldn't get enough heat, so I retinned just a very, very little bit, barely touched that, and now it immediately takes that solder. Again, touching both the lead and the pad, and just a smidge of solder. You can really push way too much solder on and start gobbing it on, and all that does is gook up your iron that needs to be wiped off, because it'll fill the pads similar to the way it did the first time. Trim those leads off, and we'll just take a quick look at it up close. So those are pretty good little soldering Hershey Kisses, I guess they look like. So, all right, that's Soldering 101 with a non-soldering expert.